Hello there UILCS coders, and in this video we are going to cover the bubble sorting algorithm. The bubble sort algorithm is a sorting algorithm where the largest value will bubble up per iteration. So what does that mean? Well, let's say I have an array of 5, 9, 4, 8, 6, 3, and 2. Basically what bubble sort does is it compares the sequential values and sees if this value is bigger than the value next to it. If so, it'll swap. If not, we keep on checking. So in this case, 5 is not bigger than 9. So we're going to check 9 and 4. Well, 9 is bigger than 4. So we're going to swap them just like this. And now we're going to keep on checking. So we're going to check 9 and 8. Well, 9 is bigger than 8. So we're going to swap them. Let me just make this a normal color. 5, 4, 8, 9, 6, 3, 2. Well, 9 is bigger than 6, so it's going to get swapped again. And then we're going to swap, because 9 is bigger than 3, we're going to swap it again. And then lastly, 9 is bigger than 2, so we'll swap it one more time. 2 and 9. So as you can see, 9 actually sort of bubbled up. It went from this position, like over here, to all the way to the top of our array list, right? That's what I mean when it says the largest value will bubble up per iteration. And what I mean per iteration, this all happened in the span of like one for loop, right? We just looped through all this. So bubble sort basically a nested for loop. So we're going to do this again. We're going to cycle again. So we start at 5, compare that with 4, 6, 3, 2, 9, right? Then we're going to compare 5 and 8. Nothing's going to swap there. I think it might be more clean if I just do it on this line. Right, 5 and 4 will swap. So let's just indicate that like this. 5 and 8, well 5 is less than 8, so it's not going to swap. 8 and 6, well 8 is bigger than 6, so we're going to bubble 8 up like this. 8 and 3, well 8 again is bigger than 3, so we're going to swap it like this. And lastly, 8 and 2, well 8 is bigger than 2, so we're going to swap it yet again. So as you can see now, 8 has bubbled up to its final locked position, right? And you may be asking why we didn't check 8 and 9, because when we bubbled up 9, 9's already sorted. 9's already sorted. So we don't need to check it again. Now we've sorted 8, so you can see I'm indicating the sorted element in red. So let's copy this, if I even can. Yo, there's no way. Let's just copy like this. 4, 5, 6, 2, 2, and then let's just copy over to 8, 9. Okay, we'll keep doing that again, right? 4 and 5, nothing changes. 5 and 6, nothing changes. 6 and 3, we're gonna have a swap. And then 6 and 2, we're gonna swap, right? We're gonna bubble up 6. And now we have 6. 6 is now in its final position. We're not comparing 6 or 8, 6 to 9, because those are already locked, and that's just gonna waste time. It's gonna be inefficient for our coding algorithm. You're going to repeat this again, 4 and 5, nothing changes. 5 and 3, well actually, 5 is going to bubble up, it's going to go up here. 5 and 2, well 5 is bigger, so we're going to swap it again. And now we have 5 in its final position. And we're going to keep swapping, so let's Or I probably should have done like this. Sorry, that's my bad. Let's just do this, and let me just do this. So you can see each number. Yeah, like this, right? Sorry, it's just formatting stuff. So now we'll repeat this loop again. 4 and 3. Well, 4 actually is bigger than 3. So we're gonna swap it. 4 and 2, well, 4 is bigger than 2. We're gonna swap it again. 4 now is gonna bubble up to the top, as you can see. And now we're on our second to last iteration. So over here, we're going to compare 3 to 2. Well, 3 is bigger, so we're going to swap them around like this. And now we can lock U in place like that. And then this is actually where our loop stops. We don't really do one more iteration because the last element is by default sorted, right? There's nothing else to compare it to, so it's the minimum. So this pattern here, you can see if you really just want, you could look at this from here to here. This is the bubble sort. We're basically swapping each value. So swapping this and swapping this and swapping this. Or not swapping, but more like saying if the number is bigger, we're swapping. So that way we insert the biggest values, we can bubble up to the end. Now let's look at this in code. So I'm going to create a new Java class and call it bubble sort. Or we'll just call this sorting algorithms. Because I have more we're going to go over. Let's do that same array. So what were the values I had? I did 5, 9, 4, 8, 6, 3, 2. So let's create an integer array r equal to 5, and I need to check the numbers again because I like how to mention. Not really. 5, 9, 4, 8, 6, 3, 2. Yeah, okay, good. So we're gonna call bubble sort, although we haven't defined it yet on this algorithm. And then let's just do 4 int num in array. Let's just it's just there's no like print by itself. Let's print on that num plus one of these, and then we can just, or we can't, yeah, that'll be good. That's fine. So you might be saying, yeah, now we need to define a bubble sort. So let's create this, right? Bubble sort into R. This is our signature. So what did we say originally? Well, we need to be able to essentially loop through this and this swap. That's how bubble sort is. We're gonna loop through it every single time we're doing a loop, right? 0 loops. And we're essentially in the loop, we're going and finding the maximum value and swapping that and bubbling that up to the top. So you can say if we have a series of loops in a, we can put that in a loop, we have a nested loop. So we're going to do that. So we're going to say int is equal to 0, while I is less than r dot minus 1. Remember we're doing, or well, you'll see my later. I'm making it 20 right now. So next we can do is going to create our new j equals 0. J is less than r dot length minus I minus 1. We could do minus 1 minus I, doesn't matter. And then we're going to do j plus plus. And all we do, okay, so essentially all we're doing here is we're going to compare r of j, see if it's greater than r of j plus 1. Or sorry, this would be, yeah, this is fine, this works. So if this is true, remember what we said? We said if it's greater, like in 5, 4, we want to bubble up, right? We want to go and move on. So what we are going to do is just store this as a temp variable. We're going to do basic Java sorting. And we're going to say r j plus 1 is going to be equal to temp, and r of j is going to be equal to, sorry, this is just not right, and this should be, okay, array should be like this. rj plus 1. Okay, so now we have each of the variables shifting, and that should actually be it for bubble sort. So if I run this algorithm, yep, you see we get it all fully sorted. So what do we do here? Like I said, we had a nested for loop. The inner for loop basically would run through all of our non-sorted elements, which is what this does. And it'll check if the element is bigger than the one before, or if it'll check if the element is bigger than the one after it, and if so, then we swap it. We push this element forward, just like we saw over here. We bubbled that element up, right? 9 was bigger than 4, so we bubbled it up. 9 was bigger than 8, so on and so forth. We bubbled it up. That's what this does. That's what this swapping does. We're swapping it. And we're doing r.length minus 1. Now you don't actually need this in your program. If you run this, you'll still get the same output. But the reason you do this is because this basically makes it so. Remember how I said when you have just one variable by itself, like when this was just 2, we didn't do a whole nother loop cycle for that, right? Because we know it's just by itself. We know it's right. That's what that does. That is what that handles. And yeah, that's going to be bubble sort. Now there's actually something I want to talk about bubble sort regarding its time slash space complexity. So bubble sort, as you saw, it's just a nested for loop. So best case is O of n squared. Average case is O of n squared. And then lastly, worst case is also going to be O of n squared. Now there is something, a little note to put here, that if we were to have a check if no swaps are made in here, so if we were to have a conditional variable, like a boolean, that checks, so if we had a flag in our code, we could simplify. Our best case could be O of n. And so let me actually code this to show you what that look like. So what we're doing with the flag is basically saying if no swaps have been made, if we haven't swapped any variable around, we look through the entire list, nothing was bigger than the other, and that means everything is sorted. So I can go up here and I can say boolean is sorted, say it's false. Then if this loops, and then here we can say, or actually we can, I think it might be better say it's not sorted. Really that's false. And then if this is run, we say not sorted is true. So what not sorted is doing is checking to see if basically not sorted will ensure that what we've passed in is not a fully sorted array. So what we can do is in here we can say if not sorted is equal to false, then I just want to return. Or you can simplify this to not sorted. So if sorted, if our array is already sorted when passing in, right? I'm not going to see much change with this one. It's going to be the same, but this does speed it up a little bit. But that's only if you have the flag. So if you don't have the flag, this is true for time complexity. For space complexity, it's going to look something like this. Your best is O of 1. Your average is O of 1. And then your worst is O of 1. And why is this? Because we're just working with one array, but the whole thing, right? Essentially, all this is just a loop, and all it's doing is editing one array. There's no recursive calls, there's nothing to increase the stack size or anything. All we're doing is working with one array, so it's going to be pretty much constant size. And yeah, so that was bubble sort in Java.